Farmers have always depended upon them to grow their crops. Now they're using these elements, plus waste material, to produce additional energy. John Lorenzen of Woodward, Iowa, is a pioneer when it comes to harvesting energy from the elements. In his 40 years on the farm, he's never had an electric bill. His power company is Mother Nature. Wind whirling the blades above his farm buildings generates power which is stored in heavy-duty batteries. If the wind dies down, fully charged batteries can carry him for 8 to 10 days. From here, power flows to all the lights and appliances in the house and shop. More recently, he has added solar collectors to help keep him warm while he works. The day may be sunny or cloudy and windy. Either way, the elements are working for John Lorenzen. In northeastern Nebraska, 50 farms were selected to test low-cost on-farm energy systems. Cooperators in the program, called the Small Farm Energy Project, have proved you don't have to spend a lot of money to put sunshine to work. Gary Young of McLean built his solar grain dryer to travel on an old running gear he had around the farm. At grain drying time, he brings it down to the barn, attaches the flexible duct, and draws warm air inside to dry the crop. In the winter, he uses it to supply solar heat for his house. He also built this $625 collector on the wall of his dairy barn. It makes it more comfortable for the cows and for Young's daughters who do much of the milking. Young reports saving 40% on the cost of fuel to heat his house and dairy barn and dry grain. According to Edgar Webben of Wynot, he reduced his water heating costs 50% by letting nature heat the water for his milking parlor. With the help of others in the project, Webben built this solar heat collector on the roof. Water heated up here is drained into an insulated tank below. It's then piped to meet the various needs of his milking operation. He also built a solar food dryer, which Mrs. Webben uses for drying fruits and vegetables. Attached to the house is a solar collector wall that Webben built for $600. It delivers heat inside the house in the winter and substantially lowers fuel costs. Earl Fish of Belton built a wraparound solar collector to dry his grain. Fanned inside the cylindrical building, the warmed air dries 6,500 bushels of corn every fall with no additional heat source. Fish added the solar unit at a cost of $485. Since then, he has also added this solar house to his home, a pleasant oasis for both plants and people.
Solar. The reason I use solar energy is because it heats my home. Yeah, I dry my grain with it. We're not going to run out of it. With energy costs going skyward, why, it's the route for me to go.
At the Department of Agriculture Research Center near Bushland, Texas, they're testing wind assistance systems for irrigation purposes. Wind assist means the windmills are used in conjunction with electric motors or other power sources. This vertical axis mill is used in conjunction with a diesel engine to operate a pump in a deep well. A wind turbine like this one may supply all or most of the power on a windy day, saving electricity costs, while the connection to a utility power line is assurance of year-round operation. Dr. R. Nolan Clark, research leader here for agricultural wind energy research, speaks of their progress.
2 years ago, the energy from wind machines was costing 15 cents per kilowatt hour. And because of new technology developments, today this same energy is costing 7.5 cents per kilowatt hour. We project in 2 to 3 years the cost will be 4 to 5 cents, which is less than most people are paying for electricity today.
In nearby Tulia, farmer Stuart Kirkpatrick is helping field test such a system. The 3-blade wind turbine connects to an irrigation pump and an electric motor generator. Right now, the utility line is powering the irrigation pump. But as the wind turbine picks up speed, it shares the mechanical load of the pump, and the use of utility power slows or stops as wind power takes over. When irrigation water is not needed, the windmill is disconnected from the pump and generates electricity that can be sold to the utility company. Dr. Clark says,
because of the advances that we've seen in technology in the last 2 years, we're very excited about the future of wind power for agricultural uses.
There's also a growing interest in producing methane gas on the farm. At Mason-Dixon Farms near Gettysburg, Pennsylvania, the cows not only produce milk, they're also working in the utility business. Here, 700 Holsteins provide liquid manure to produce farm fuel. Water mixes with and flushes out the manure. The liquid mixture flows out of the barn into a nearby settling pond. From here, it's pumped into a concrete-lined pit beneath this plastic bag. Here, bacterial action converts part of the manure into methane gas, which collects in the bag. The facility was built with the advice of experts, as safety precautions are important when dealing with methane. This gas is then pumped to a methane diesel engine, which drives a 125 kilowatt generator, supplying electrical power for farm operations. The liquid manure is recycled after it comes from the digester, separating and drying the remaining solids. The dried residue, now a relatively clean and odor-free material, goes back to the barn as bedding for the calves. And the separated water goes into a farm pond to be sprayed on the fields for irrigation and fertilization. Dick Waybright, a stockholder in the family-owned corporation, says they invested about $90,000 in the methane system, and it's paying off.
Last year, we used about $30,000 worth of electricity here on the farm. Since we built our digester and have had it in operation for about 9 months, we've proven that we can produce most of the electrical needs here on the farm with the present digester. I personally believe that in a matter of 4 or 5 years, most livestock farmers with 50 cows or more will want to go with such a system.
Like a growing number of concerned citizens, these farmers are exploring practical ways to make their operations more energy self-sufficient.